Hello everyone, welcome to the next lecture on the PY question series. Today we will discuss about inner product problems. Myself Dr. Harish Garg, I will cover all those questions from the year 2011 to 2023 related to the CSIR net examination. Myself Dr. Harish Garg, you can simply follow my YouTube channel where you can find the playlist of the CSIR UGC net and you can see all those PY questions related to the topic wise as well as the subject wise from the last 12 years. Also you can see some videos related to the statistics and the complete PY question of that topic and the subject wise available. So before I start with this PY question series, I will tell you some simple shortcut tricks so that you will be able to solve any question related to the inner product easily. First of all, what is the inner product? Whenever they are talking about the inner product, you have to satisfy these four properties. That is the positivity, symmetric, additivity and homogeneity. If any one of these function is not satisfied by this property, then we can say this is not an inner product. The most important thing is you have to read the statement carefully and find whether it's an inner product, what kind of the inner product is there. If it is a standard inner product, then it's nothing but my dot product, the dot product of the elements of the x with the y. If you are working on the matrix, then this standard dot product or standard inner product is trace of x transpose y, or you can see a simple double summation of the element wise multiply. Another concept is if you want to prove it's a norm is denoted by here, then if it satisfies these three properties, you can see there is a difference between them. Here the additivity or called as the triangular inequality, it is satisfied as a equality, while the norm is satisfied as inequality. Fine, and the rest of the positivity and homogeneity is the remain same. Here it's a r, but if you're talking about the norm, then it's the absolute value of the r. Some standard norms are like of the 2 norm is a root of this. It is also called as the Euclidean norm. 1 norm, that's a maximum or some absolute sum of this. Infimum norm, that's a here, and p norm is generalized as here. Now based on these simple 2 tips are there, we can solve each of the questions in this lecture. We will cover the 40 plus questions in this lecture so that you can solve its problem very well. So I start with the June 2011. What is that? Xi is the cube fifth root of the unity. It means xi raised to power 5 is my 1. This is given to you and you can see this is my diagonal matrix. So once it's a diagonal matrix, is a very simple, you can solve that. You can see I can return this number as of this. Fine. It's a diagonal matrix, it's a symmetric matrix, so we can write this number as of this number. Fine. So which is nothing but my norm of V. Now how you can find the W? So since W is given to you, you have to find this value. Very simple. Look at the first element, it is my A11. So you can take the first element of this A11 into xi minus of 2 into transpose. Transpose is again the first element. Plus this is my A22. Take the 2 elements this xi of -1 of -1 plus A33. A33 is my 1. So 1, 1 and 1. Similarly for this 1 xi 1. And the last one is -1 xi square -1. Now you can see what is the answer. This is the xi square, xi raised power -2, -1, 1, this and here. What is that? This is nothing but the sum of the roots of there. Now you can see that it's a fifth root of the unity. So sum of the root will be my 0. So the answer is my 0. Otherwise you can take it as a LCM. You can take as a 1 by xi square and you can multiply them, again you will get as here. So you can see the sum is my 0, so the answer is my 0 is the right answer of the problem. Again you can see xi is the cube root of unity, so xi cube is my 1. It is a diagonal matrix, fine, which is a symmetric as well. So now this is given to be here. So the first element xi of -1 of 1. Plus second is 1 with the help of 1 and 1. So 1, 1 and 1. The third is 1 xi and 1. So which is come to be minus plus and here, which is again, because the sum of the root is my 0, so the right answer is again A is my correct answer. Look at this another one. V is the inner product space of the linear polynomial of this, which is the following is the orthonormal. So as I tell you in the earlier tips of my previous lecture of the inner product space, you can see this is my previous lecture on the inner product space of the gate examination only, but right now we are talking here. So if you have the two vectors u and w, v and these are called to be orthonormal. So if it satisfies the two properties, the first one is the inner product must be 0, second one is the norm should be 1. Fine. Now we look about that. The first element is norm is 1. Can you say the dot product inner product of this is a 0? You can see 1 to 2 is a 1 into x, so the answer is 1 over 2, which is non-zero, so this option is cancelled. Similarly for here, it is 1 to 0, x root 3 of dx, it is root 3 over 2, which is non-zero, so this option is cancelled. Look at this one, it's 1 to 2, 2x minus 1 of root 3, so it is x square minus x of root 3, 0 to 1, it's a 0, so it satisfied first property. We can check about here, it's x minus half, so this is my 1 over 2 minus 1 over 2, 0, so third and fourth satisfied this property. Now look about this one, I can check about the norm of u is 1. So what is the norm of u? It's a u of u. Fine. So if I take x minus half into x minus half over the 0, 1. So what is the integration of this? X minus 3 over 3 over the 0 to 1. So if you take as a 1, it is my half raised power 3 minus, if you take as a 0, it is minus half. So can it be 1? No. It's a 1 over 24 plus 1 over 24. So this is not satisfied. Only right answer is my C is the right answer. Look at this another one. R cube is the standard inner product, that is element wise. Fine. W is the subspace of 1, 0, minus 1. Which of the following is the basis of the orthogonal complement? You have to find this property. Fine. So now we all know the W and this orthogonal complements dot product inner product is always 0, and because they are the elements of the R cube, so we all know dimension of W complement is nothing but my dimension of the R cube. So this has the dimension 1, R cube has the dimension 3, so this must dimension of 2. So look at that, this is a 3 dimension, this is a cancel out. Now what is the meaning of the basis? It is a Li. So can you say which of the following is not Li? You can see this is not Li, because if I call this is alpha, this is beta, then 2 times alpha is nothing but beta, so they are not Li. It's a not Li, it means not basis, so this is cancelled. Now you can see here, you can check, because my W is 1, 0, minus 1. Check the inner dot product of this W with the first element. Is it 0? You can see 1 plus 0 minus 1, 0 is satisfied. Check about this other 0, 0, 0 is a 0. So this is the answer. Look about the second one. If I take 1, 2, 1 dot product of this 1 plus 0 minus 1, 0 satisfied. 0, 1, 1. If I take 0, 1, 1, it's a 0, 0, minus 1, it's a minus 1, non-zero, so this option is cancelled. Only option is my A is the right answer. You have to read the statement very carefully, because they are talking about the basis. So basis means Li, orthogonal complement means this, and we need the dimension of this, because all the dimensions are not same, so we can check about the dimensions as well. Okay, look at this one. A linear transformation T rotate each vector of the R square through the 90 degree, then the matrix relative to this one. Very simple. You can write on graphically. Where is the 1, 0? This is 1, 0. This is 0, 1. Now you can rotate through 90 degrees. So you can rotate through this one. So once you can rotate, what will happen? This is a A, this is B. So A becomes here and it's a 90 degree. So now B is my here. So what are the coordinate of this B? This B will be my 1 comma 0. This A will be 0 comma minus 1. So it means what is the matrix here? What is the A? A is my, because this value is my A, this is my B. So A becomes 0 minus 1, B becomes 1 comma 0. So what is the right answer of this is A is the right answer. No, sorry, it's a minus 1, but we need a plus 1. It's a cancel. 0 minus 1, yes, this is a B is the right answer. It's a cancel, it's a cancel. So B is my correct option of this example. You can see it's a very simple, you can just read the statement very carefully, you can get your answers very much. You can scan and join my WhatsApp group also if you want to see some discussion more on this group. Okay, look at this another one. A is given to be here. This I can, because you can see what is the A? A is my symmetric matrix. So I can return this value as of this. Remember, if I write this number, so in terms of this I can return this as transpose of V, so which is W transpose A transpose B, but A is matrix, so A is nothing but A transpose. So this is as here. Fine. Then which of the following is my correct statement? I think it's very simple. Look at that. What is the A? So eigen, because whenever there is a matrix, think firstly about the eigenvalues. Eigenvalues are my 1 minus 1. Fine. Now there exists an eigenvector of V such that AV is perpendicular to, so it means I have to prove the inner product must be 0. Fine. So what is the V? You can take any of the V. It's on your choice. I can simply take is R2. I can simply take E1. That's a standard basis of this. So what is my AV? A is my this, V is my this. If I multiply them, it will be my 1 comma 0, which is nothing but V. Fine. So clearly says if I substitute on this value, what is that? It's a V. It's a V. So what will happen? It's nothing but V square. Fine. So which is non-zero, because V is my non-zero element. So it means they are perpendicular, they are not perpendicular. Look at this one. The set collection of all those such that V comma V is my 0. V comma V is my 0. So that's a very simple again, because they are the same elements. I call as a V1, V2, V1, V2, same elements. So if I multiply them, it's a V1 square minus V2 square is 0. So what is that? What are those V's? It means this is nothing but plus minus V. So it means if I call as one is X element, second is plus minus X. Then it's a subspace. Is it a subspace? Clearly say it's not a subspace, because if I take the one element as 1 or minus 1, other element is 1 and this, then what will be the addition? 2 comma 0, which is not the part of this one. So therefore it is not subspace. V and W are the two non-zero vectors such that their images are same, then they are scalar multiples. Again, very simple, you can think about this. If I consider this value, so what will happen? It is nothing but V square minus W square. So clearly says if I take 1 and 1, 0. If I take 2 and 2, then it's a scalar multiple. If I take 2 and minus 2, again it's a 0. But can you write 1 comma 1 is a scalar multiple of this? You can never write. So it's a scalar multiple, is cancelled. So the right answer is my D is my correct answer. But how D is the correct answer? Again you can see this is my here. For every V, so I can choose the value of the V is say my 4. Fine. There exists, remember they are talking about there exists, not for all. There exists a V such that this value will be 0. So you can see I can choose, you can choose a W as a minus 4 or W as a 4. So it means there exists. If they are talking about for all W, then again this option is cancelled, but there exists. So that's why the right answer is my D is the correct answer. Okay, look at this another one. A is my n cross n. Firstly, I can choose n is my 2. So A is my 2 cross 2 self-adjoint matrix. So I think all of you know what is a self-adjoint matrix. A is any of this, because they are not talking about the real, or okay, they are on the complex. So A is a Hermitian like. Then P of A is a polynomial of, okay, with their eigenvalues, they have the eigenvalues lambda 1 and lambda 2. Then your target is to find the supremum over this norm x over this here. So we all know this is less than of norm of P of this into norm of this, but we have to find the supremum over the norm 2 is 1. So this value will be 1. So it is less than of, it's a supremum. So now it is my supremum of this. Fine. Now you can see what is the P of A. This is my there. So if A has eigenvalue this, what is the characteristics equation of the P of A, which is A0, A1 lambda 1, A2 lambda 2, and up to An lambda n. Fine. Or if I call as a J, so if I call J is a square and here, so that is my supremum is nothing. Now it's a characteristics equation. It's a maximum of this. So this is minimum is not be there. It is not, because it's a modular sign. So this option is also cancelled. B is my right answer. Okay, R of n is here, which is for firstly n cross n. I can choose n is my 2. So A is my 2 cross 2 matrix, such that their columns are my V1 and V2. What is the nature of these columns? These columns are my orthonormal. So what is the meaning of the orthonormal? Means the dot product or inner product is my 0 and the norm of each value will be 1. So which of the following is there? So very simple. So we all know a matrix whose columns are my orthonormal, then the matrix is said to be orthogonal matrix. Fine. The matrix is said to be orthogonal matrix. Once is said to be the orthogonal matrix, it means A into A transpose is my identity. Fine. So A is equal to A inverse, cancel. A is equal to A transpose, cancel. A into A, I can written this as A into A transpose is I is the right answer. Now what is the determinant? Now we all know what is the eigenvalue of orthogonal matrix. Our eigenvalues of the orthogonal matrix are my plus minus 1. So what is the determinant of this? It is my 1 and minus 1. It's a minus 1, but he said plus 1. So this option is also cancelled. Correct option is my C is the right answer. Another way, you can think about any of the orthogonal matrix. So we all know this is my orthogonal matrix, or this is my orthogonal matrix. Fine. So that the dot product is a 0. So clearly says the determinant is my minus 1, but he said plus 1. So that's why this, by using this matrix, it's a cancel out. A is equal to A transpose, all are satisfied, but they are not satisfied this orthogonal property. Okay, consider the two subspace W1 and W2. W is also subspace. Which of the following is there? Fine. Okay, can you find the W1 elements? The sum will be 0. So first of all, what is the dimension of this W1? So it's R cube 3, because it's a 0, so we have to find the nullity. What is the rank of this? Rank is my 1. So that dimension is my 2. So the sum will be 0. I can take 1 0 minus 1, or I can take either x is 0 then y is minus 1. So that's the span of this. Can you find the elements of W2? It is my, again, dimension of W2 is 3 minus 1 2 again. So that x plus z is my y. So I can say x z is this, so y will be my 1. This is the first pair. Second is, if I take x is 0, y is 1, then z will be my minus 1. Fine. W intersection W1 is given to be the span of this, which is fine. And What is the meaning of orthogonal is the dot product is my 0 because it's the usual product. Which of the following is my? Very simple again. Firstly, if W is my here, can you find W intersection W1? This is my W1. What is the intersection part is? You can see this is my intersection part. 0, 1, minus 1. Fine. Now, what is our W intersection W2? Because we need of this. W intersection W2. It is, which one is there? None of them. Okay, but it's a spam of this. Can you make them as W intersection W? So, now this is there. Fine. So 0, 1, minus 1. So this is W intersection W1. This is W intersection W2. Is it W intersection W1? Fine. So now, can the dot product is a 0? Can the dot product is a 0? So you can see it's a 0 plus 1 plus 1. It is not 0. So can you say it is orthogonal? It is not orthogonal. So you can check whether it is 1, 0, minus 1. Fine. So W intersection W1 is my spam of this, but it is not the part of this. You can say is my here. Fine. Because it's a spam of this, so we can generate is also it's a spam of this. So definitely it's a part of the 0, 1, 1. So can W and this, they are orthogonal? 0, 1, minus 1, 0. So that means this is satisfied. Look at the second option. What is the W? W is, you can see, W is nothing but my W1. This is the same of this. Fine. Now, can you say, so what is the meaning of this intersection W1, which is nothing but my W1? Fine. So, but W1 is not the spam of 0, 1, 0. Why? Because you can see that I need, if I take the spam of this, it is a minus of something, but we need a plus, which is not the spam of 0, 1, 1. So this option is cancelled. Look at this third one. What is that W? If I take W is this, what is the W intersection W1? Is there any element common? The first element is common. 1, 0, minus 1. 0, 1, 1 is not there. Okay, what is that W intersection W2? Is there any element common? Is there any element common? No. So what you can do, you can check whether the dot product of this, that is orthogonal of this with the element of the W2 is a 0 or not. The first element is 0, first element is not satisfied. Fine. These are the 1, 0, 0 not satisfied. This option is cancelled. The next one is W, the spam of this is, can you get the intersection, this portion? Okay, you can see that I need a W intersection is second element is non-zero, but here you can see the second element is always 0. If you write as a spam, the second element is always be a 0, but it is not as part of this here. So it means this option is also cancelled. Right option is A is my right answer. Okay, look at this another one. V is a vector space of degree at most 2. Whenever there is a question related to the polynomial of degree, always think about the basis. It's a polynomial variable t. Fine, these are my basis. Then the inner product is defined to be this complement, orthogonal complement. Then it means this value must be 0. Then H belongs to the W complement and F and B as the spam of this. Okay, fine. H is an even function. Which of the following is even? The first part, that's the t square. So if I take this element, if I take that dot product of, this is my W complement, of any element of this, I consider as a 1 minus t square. So what is that? It's a 0 to 1 t square of this. Can it be a 0? You can see integration of this is 1 by 3. It's a 1 over 5, which is non-zero. So this option is cancelled. It means this value can never be here. Look at the second one is H is my odd function. So odd is my t. So then you have to take, one is a t from the H complement, one is from the W. You can take any of the number. I can take this. What is the integration of this? 1 over 2, 1 over 4. Again is a non-zero. So this number is cancelled. Look at the remaining one is h of t is my 1. So clearly say h of 0 is non-zero, is also cancelled. C is my right answer of the problem. You can see within a couple of seconds you can solve it easily. Read the statement very carefully. Okay, let P is by here, for which is the inner product. Okay, now a new tips for you. Whenever you want to prove whether it's an inner product or not, and there are the two variable problem, fine, then your target is to construct a matrix, check whether this matrix is symmetric or not. For example, here how many variables are there? It's a 2 variable. So I can construct the matrix corresponding to this x1 x2, second is y1 y2. What is the coefficient of x1 y1? A square. Coefficient of the x1 y2 is ab. This is ab, this is b square. Fine. Now you can see, is a symmetric matrix? Yes, it is a symmetric matrix. Once you form is a symmetric matrix, then prove that. If you prove it's a positive definite, if you prove it's a positive definite, then it means it is my inner product, otherwise not. Fine, that's a simple shortcut tips for you. If it is a symmetric matrix, prove that it's a positive definite. If it is a positive definite, it's an inner product. How you prove the positive definite? You find the principal minus, or you can find the eigens value. If you prove all those eigenvalues are my greater than 0 of this, then it's a positive definite. Otherwise, find the principal minus. How you find the principal minus? First value, first diagonal a square, which is always greater than 0. Second principal minus is determinant of this matrix. It's a square minus a square b square, which is it is not greater than 0 for all a comma b. It means it is not positive definite, it means it is not inner product. So for what value of the a and b? There is no value of the a and b for which this is my inner product. So that is a simple way. Which of the following is an inner product on the vector space? Fine, very simple. What is the inner product? Because it's not a 2 cross 2. So remember that. We all know the modulus value, whatever the modulus is there, it is not an inner product. Why? Because we all know we have to prove the inner product is must be of this nature. Fine. Remember, it's an equality. But whenever you take as the modulus value, it is my f1 plus f2 of modulus. It is not equal to f1 plus f2. Although it is a less than or equal to f1 plus f2, but we need an equality. So it means the first option is cancelled out. Like, if you want, I can write quickly for you here. It can be written as absolute value f1g plus f2g. Now how you can do that? It is less than or equal to f1g plus f2g. Fine. Now if I open this bracket, it will be less than or equal to f1g and f2g, but we need a equality, so this option is cancelled. Always remember, whenever there is a modulus value, it is not an inner product. Similarly, again, it is a modulus value, it is not an inner product. Look at this. This is a particular value. Very simple again. You can consider any of the function like f and g both are same. Then this value, it is greater than 0 for all f which is non-zero, and if it is 0, then your f must be 0. Fine. Now what you can do, I can choose a one function, it's a 0 and 1. I can choose a one function over this domain, 1 minus x, or you can choose as a x minus 1 to x, lies between 0 and 1. So what is the value of the right hand side? What is the f of 0? 0. G of 0, because f and g both are same, 0, 0. So this value is my 0, that is this property is satisfied, but f clearly says this number is my non-zero, so it means this property is also not satisfied. Right answer is my D is the correct option. Okay, first of all is n cross n. I can choose n is my 2. So A is my simple 2 cross 2 real symmetric matrix. Fine. Then you have to prove the trace of this. Again, very simple. We all know the inner product is always be a greater than or equal to 0. Can you think about any of the matrix A and any of the matrix B such that the product of the trace is a negative? Then this option will be cancelled. So you can see if I take 1, -2, 0, 0, it is 1, 2, 0, 0. So what is that trace of this? Trace of this is -1. Trace of B is plus of 3. If you multiply them, it is the less than 0. So it means this option is cancelled out. You can see also, if I do the same example, it's a -1 plus 3 is a greater than 0. But if I do this one as a 21, then the trace will be my 20. Then this value will be -20 plus 3. Again, it's a less than 0. This option is also cancelled out. Can you think about the trace and the determinant? We can check about the determinant firstly. If I simply take A is my, how you can think about that? If I say A trace or determinant, so AB, if I say A is equal to B, then your target is to prove A of A is my 0 if A is my 0. So if I simply say A is my here, B is my this, what is my AB? AB is also same. Fine. So what is my trace of AB? Is my 1, which is greater than 0. But what is the determinant of AB? Which is 0. So it means A comma A is 0, but this case you can see this is not the 0 matrix. So this option is cancelled. Only right option is my B is the right answer. Look at this another one. T is the linear transformation on the R raised to power n. Take R n is 2 such that T square is my this value. For some this. Then T of x is my here. You can think the given number is the T square, but they are asking about the T of x. It means you have to remove this T. Fine. How you can move that? I can multiply by T. I can see this number is nothing but, if I pre-multiply by T on this, then it will be my here. Fine. If I multiply by T inverse on both sides. Clear? But is it given that the T inverse existence? No. It means this is happen only if T inverse exists. That means determinant of T is my non-zero. So I can take the one counter example whose determinant will be a 0. Say any number. Say 2. I can't take as a 1 because if I take a 1, then it will be my 1. Okay, I can simply choose as a 1 for the simple calculation. Say 1, 0, 0, 0. Clearly says determinant is my 0. Fine. Now, can I find for all x? You can choose any x from the, so I can simply take 1, 0. So what is my T of x? 1, 0. Fine. If I take x into this 1, 0. Can you see this number is my 1, 0 of lambda is eigenvalue. So what is the eigenvalue of this? Yes, it is 2. But if I choose x is my 0, 1 is a for all. So what is my Tx? This is my 0, 0. So can you say this number is? Yes, because 0 is also the eigenvalue. So it is 2. Okay, I can choose the another number. What I can do is, instead of the 1, if I change them to be say 2, fine. Then if I choose this value, what is my Tx is 2, 0. Can you say this number is here? Fine. Because x, so it means T of x is my here. It is satisfied, but does it satisfy this property? What is my T square? It is my 4, 0, 0. So I can say it is my 2 times 2, 0, 0. That is my 2 times of T. It is satisfied. Fine. Okay. For all x, he said for all x. So if I simply take x is 0, 0. Fine. What will happen of the Tx? It is a 0, but it is not equal to lambda times of x. Fine. So what is the meaning of that? This option is cancelled because you can get here. Second option is if now this condition hold. So t of x is mod x. When this condition hold, clearly says norm of t is my here. What is the meaning of that? It means t is my invertible, or I can return this number as tx. Tx is nothing but x and x. Fine. I can return this as x t star of tx, or t transpose is x comma x. So if you compare them, what is the meaning of that? This number must be 1. So what is the meaning of that? This is my orthogonal matrix. So 1 is the orthogonal matrix, but the eigenvalue of this is a plus minus 1. So it's a correct option. T is equal to lambda I. This is happen only if t is my invertible, as I discussed here. But it is not given that. I can again simply take this value. Fine. If I simply take this value and clearly say this is not equal to 2i, although this satisfied this value. Fine. Where the 2 is the any value. So, but it is not satisfied. Now look at the last option. If I take t of x is greater than x, it is given to you, then it's a necessary singular. It means determinant of a is non-zero. That's your target. If I do the same example here, fine. So what is the meaning of that? If I take t is my this value, then what is my tx? It is my simply a 2x, whatever the x is there. So if I take the norm on both sides, it will be my here, which is 2 times. Is it greater than of this? Yes, it satisfied this condition, but clearly says that determinant of t is my 0. So that means it is a non-singular, but the given set is singular. So this option is also cancelled. Right option is only B is the correct answer. Okay, look at this another one. A non-zero with the inner product space. Which of the following are the subspaces? So clearly say it's a 1. It's not a subspace because 0 element does not belong to this. It's a 1. 0 element does not belong. It's a not. It's a 0 element here, and it's a inner product space. It's a yes. It's my inner product space, and it's a subspace. Again, it's a 0. It's a 0. So yes, it is also the subspace. A and C are my correct answer of the problem. Okay, look at this another one. These are the inner product space satisfying this. Which of the following properties are satisfied? So we have to check which of the following are true. Okay, look at the first option. How you write this value? I can return this number as this comma this of here. Fine. Now I can open this. It will be my w comma w plus w comma v plus and so on. Now I can directly substitute the value. What is the w comma w? W comma w is my here. It is now it's I can return this number as w comma w is my 2 square. Fine. So this number is my 4. Then second is w and v. W and v is my minus 1. W and is a minus. W and u. W and u is my plus 1. Fine. Then v and w. V and w is my minus 1. V and v. V and v is my 2. So it is my 2 square. Then v and minus of u. V and u is my 0. Plus. Now it's a minus u and w. U and w is plus 1, minus 1. So it is my minus 1. It's a minus vu. Minus vu is 0. Minus minus plus u and u is my 2 square. So what is that? It's a 4. It's a minus 3 plus 4 minus 1 plus 4. So what is that? 3, 3, 4. 4 is cancelled. 8. But you need a norm. So I can return this number as this is 8. So what is the value of this value? It is 2 root 2. It's a satisfied. Now look at the second option. I can clear this screen. So first option is correct. They are the orthonormal. So your target is to prove dot product of this will be 0 and norm of this is 1, norm of this is my 1. So firstly I can take 1 by 4 is a common, u comma v. What is the u comma v is 0, so it is 0. So this satisfied. Look at this one, half of this. How I can return? Half of u, half of u. Fine. So this is 1 by 4 is outside, u and u. What is the u and u is? U square. It is my 2 square. Fine. This is my 4 by 4 is 1. So norm of u is my 1. Satisfied. Again this is also satisfied because it's a v comma v. It is my 2. So it's all satisfied. Is our right answer. Now look at the third option. This and this are orthogonal. So your target is to check whether this will be 0 or not. So I can see if I open this, 4 is outside, w comma this, minus is outside, w comma w. So what is the u, w and this? It is my 1. This is, so w comma w, you can see from here it is my 2 square. So 4 minus 4 is 0. So what is the meaning of that? It's the orthogonal is the right answer. Now are necessary li. How you can prove that's li? There is no need to prove that. Why? Because we already proved that. Remember, your vectors are u, v and w, and you prove that they are orthogonals. They are not orthogonal. How you prove that they are orthogonal? If you prove, okay, how they can prove it's li? So it means this value, so this number, if I prove this is my gamma of w, then your target will be this is there. Fine. This is your basic target. So but there is no need to prove like this way. The first way is you can prove, because we all know this plus gamma, if I take the dot product with u, it will be 0. But there is no need. I will simply tell you, we all knows, remember, we all knows every orthogonal set is my li. So that's a very simple, because it's, you already proved that it's orthonormal and orthogonal to each other. So it means they are my li. So that's a simple result for you. Okay, look at this one. V is a vector space of all those polynomial degree less than or equal to n. I can simply choose n is my here. So V is a polynomial of all those which is degree less than which of the following define the norm. So remember what is the norm is? So we all know first property you always try to satisfy. This number is 0 if x is 0, otherwise it is greater than 0 for all x which is non-zero. So you can see any of this property which not satisfied is a polynomial. Okay, so I can simply take any of the polynomial. What are the basis is a basis with respect to t. This is my basis. Fine. So can you think about any of the polynomial which is non-zero, and but answer is, you can see this is a derivative. If I simply take a polynomial is here, what is the derivative? 0. What is that? Supremum of p dash is also 0. So this value is my 0, but you can see this number is non-zero. So it means this property not satisfied. This option is cancelled. Now this is we already stated in the earlier. This is the infim norm, that is called as supremum norm. This, what is that? If I take n is 2, this value will be my p1 square plus p2 square and p of 3 square. What is the p1, p2, p3? I can consider this one elements. Fine. So this is a modulus value. So we all know modulus is definitely, it satisfies this norm property. All these properties are satisfied definitely. this is a supremum also, and this is again a modulus value. It's a norm. This is a norm A, B and C. Otherwise, if you really want, you can check those properties, like alpha of P is nothing but of this. You can easily see, because if I take alpha P, I can take alpha as a common, it's a mode of alpha. I can take of this, alpha is there. If I take alpha, again mode alpha. If I do like P1 plus P2, it will be less than of definitely. Why? Because of this modulus sign. The modulus of P1 plus P2 is less than or equal to modulus of norm of this plus of this. So it also satisfied. And if P is equal to 0, if and only if P is equal to 0. If I consider any of the 0 polynomial, then the coefficient of this is 0 plus 0t plus 0t square. So it's a 0, 0, 0. All are satisfied. Okay, again it's a n. I can simply choose n is my 2. Then A is my 2 cross 2 is my orthogonal matrix. Fine. So what is the orthogonal matrix they are talking about? So what is the eigenvalues of the orthogonal matrix? Plus minus 1. Fine. Once they are orthogonal matrix, then each row and each columns are Li, or you can say they are orthonormal basis. That we all know. So look at that. The rows of the A are orthonormal basis. Fine. Now look at this one. As it is Ax, Ay, which is x comma y. So can I write this number as x comma A transpose of y, which is, now when it will be happen, if you compare them, this number must be I, or it is already given to you as a I. So what is that? It is x comma y. It is x comma y, which is a true statement. So it means this option is also correct option. Whether A is diagonalizable over the R, as we have seen in our last lecture of the diagonalizable, if I simply consider this, clearly say the columns are my linearly independent, and the columns are the linearly independent, and A into A transpose 1. What is the eigenvalues of this? Or you can see x square plus 1. Characteristics equation is this, having, but it is not diagonalizable over R. It is diagonalizable over the C, but not on the R. So the right answer is A, B and C are my right answer of the problem. Okay, again is n cross n. I can choose n is my 2. So such that x comma y is equal to Ax comma Ay. It is given to you. Then which of the following define the inner product if and only if rank, eigenvalues and all here. Very simple. How you can find the eigenvalues? If I prove that this is my symmetric matrix, this is my idempotent matrix, or anything are there. So if I do like this, what is that? It is A transpose of Ay. Fine. What is the meaning of that? If I compare with this, what is the meaning of that? This is my identity. Once is identity, what is that? It is nothing but my orthogonal matrix. So what are the eigenvalues of the orthogonal matrix? So once is orthogonal matrix, what is the meaning of that? Eigenvalues are my plus minus 1. But he said eigenvalues are all positive. Cancel. All the eigenvalues are non-negative, but it is there. So it means this option is, he said all. That's why this cancel. Now, how you can say the rank? My target is n is my 2. So what is that? If eigenvalues are plus minus 1, what is that determinant of A? It is my minus 1, which is non-zero. If it is non-zero, what is the meaning of that? Rank of the matrix is a 2 cross 2. I have taken the 2 cross 2 here. So it means rank is my 2. If rank is 2, then by rank nullity theorem, rank plus nullity is the dimension of this. So what is that? Rank is 2. What is the nullity? Nullity is my 2. Nullity is 0. So dimension is my, kernel is my here. So the right answer is A and B are the right answer. Always remember student, whenever you have a matrix A always start with the thinking with the eigenvalue. You always get your answer in a very quick manner. Okay, Vn again are the elements of the Rn. For the simplicity, I can choose as n is 2. So then we have the V1 and V2 are the elements, such that norm of this is this property. Fine. Vi comma V square. For all V in the R2, which of the following is there? Basis, orthogonal, and so on. Very simple. I can start with this. Okay. So where V is the elements of the Rn. So that is these are the parts of the R2. So if I choose V is my, say, V1. You can choose any one. So what is that? It is nothing but V1 square. If I open this, now this is my V1. If I take V is my V1. If I choose this one, it is V1 comma V1 square plus V2 comma V1 square. Fine. This is given to you. Now what is that? This is the norm. Fine. So this value will be cancelled out. So what is the meaning of that? V2 comma V1 is my 0. What does it means that? It means V1 and V2, the set is my orthogonal. Fine. It is not orthonormal, because if you want to prove it's orthonormal, then your target is to prove this value must be 1. But it may or may not be, because it's an element of the R2. So if I consider 1 comma 1, so definitely the length of this is not 1. So these are the orthonormal. So are the orthonormal. Once it's orthonormal, it's not orthonormal, cancel out. Fine. Then once it is orthonormal, how you can prove that it is a basis? Basis means Li. So again, I can use the same shortcut twist for you. Every orthogonal set is my Li. Fine. So this is my elements of the orthogonal set. Every element of the orthogonal set, or every set which is orthogonal, is my Li, is my here. He said at most n is my 2. So at most one of the element can be orthogonal. Wrong option. All are my orthogonal set. So the right answers are A and B are my correct options. Okay, consider vector polynomial of degree less than or equal to n. Choose n is my 2. Fine. Then fix the next integer a, this. What is the k? K is not given. Okay, there is a condition on that. Fine. Okay, p is the polynomial of degree 2. Then you have the unknown elements of this. Fine. So what is my p? P of x. These are the elements of this. So I can say x minus a1 up to x minus ak. Fine. Now if is a degree 2, then we have only the 2 elements, and if the degree 3, then it has a 3 elements. So look at the first option. K is less than n. Fine. As n is my 2, I can choose k is my 1. So this px will be my a1. So that is only first 2 elements. Fine. Then the maximum of this defines a norm. Can you say this defines a norm? That is absolute value of this defines a norm. Yes. Can you say it's a norm or not? How you can prove that it's a norm or not? If k is less than n. So if k is less than n, how you can say it's a norm or not? It means you have to prove. Firstly, I can choose. Can you say this number is a 0? Yes. If I choose any of the x is my a0, then this number will be my 0. Right hand side is a 0, but p may or may not be a 0. How? If I simply choose p of x is my 4. Fine. P of x is my 4. Then what you can say about that? If I substitute this and x is my a0, so this value will be 0, but this is non-zero. So this option is cancelled. Okay, look at this. Firstly, we can think about here. K plus 1 is less than of the n. N is my 2 what is my k? K definitely, because k can be 0. If I take k is 0, then this number will be 1 is less than of 2, which is same of this case. So again this option is cancelled out. Now we can choose k is greater than or equal to n. If I choose n is my 2, what is the value of the k? K is my greater than of 2. I can choose k is my 3. What will happen? Your polynomial will be k is 3, x minus a naught, x minus a1, x minus a2, x minus a3. But what is the degree of this polynomial? Degree of this polynomial is 4. But what is the degree of this one is n. So therefore, and we all know polynomial of degree n of degree 2 can't be more than 2 roots. Fine. So it means this, definitely this, because this is a non-zero, so definitely this is possible. This is possible because it's n plus 1 as well. Because this is a 0 only if polynomial is 0, because it can't be more than 2 roots. If it is more than 2 roots, the polynomial must be as a itself as a 0. So the right answer is B and D are my correct options. Okay, look at this one. Again, I can choose n is my 2 for the simple norm. So if I define as a mapping T, it is from R2 to R2. Defined by here for every V which belongs to the Rn. So what are the bases of the Rn or basis of the R2? I can choose as a 1, 0 and 0, 1. Then the determinant, this is very simple. What is that W? What is the W? W is the any non-zero value. So for the sake of simplicity, I can choose W is my here. So what is my T of V? It is my, so T of V1, because I need to find the matrix. Fine. So what is the T of V1? I call this is my V1, this is my V2. So what is that? It's, I think, very simple. 1, 0, 2 times inner product of the inner product of this. That is a standard inner product. Standard means it's a dot product. What is the dot product of this and this? 1 divided by length of this, because it's a unit vector, so the length is my 1 into W. W is my 1, so what is the right answer is -1, 0. So this is -1, 0. Now we can find for the V2. What is the V? V2 is my 0, 1 minus dot product of this value. It is my 0, 1, 0. So it is my 0, 1. Fine. Now you can get as a matrix T. What is the determinant? You can see that determinant is my -1. First option cancel. Fine. Now once the first option cancel, can you say about here? What is that? This is orthogonal matrix. Fine. It's an orthogonal matrix because it has a unit length. It has a unit length and the dot product is 0. So what is that? If it is unit length, it's orthogonal. It means A into A transpose is I, or you can say capital T and capital T of this is my I, which is same of this. You can see T of T transpose is my 1. So which is same is the correct option. Now look at this second and the third. What is the meaning of that? How you can think about this? I can rub this part. Yes, I can rub this part. I can rub this part. Fine. I can move this for you as here. Now T of W1, T of W2. How you can do that? Can it be equal to this? Okay, I can again take V1 and V2 as here. So if I choose this number, this is the inner product. Okay. What are the eigenvalues? Eigenvalues are +1 or -1. So it means if I multiply this either as a 1 of this or it is my this, because 1 and -1 are eigenvalues B. Okay. Now what will happen? It is true for all. Yeah, that's true. We all know what is the inner. Okay. That's a simple. If I take as a both as a positive 1 v1 1 v2, then clearly say it satisfied. If I take both as a negative, then what will happen? -1 -1 v1 v2, so again it is satisfied. Fine. So but if I take 1 is my positive, 1 is my negative, so what will happen? This of v1 v2, which is again of v1 v2, so that means this is also the right option. Look at this another one. Look at the last option. What is that? We needed 2 times of w. Fine. So I have to firstly replace this vector here. It's a v minus comma 2w divided by 2w and 2w of 2w. Fine. So I can do this. This is my 4. I can take as a 4 common. This 4 and this 4 will be cancelled out. It will be my w 2 divided by this of here. Now you can see I can take 2 as a common from this, which is here, so it will be, so what is that? Can you say it's a 2 times of tw? No, which is same as of tw, so this value is also cancelled. Correct options are D and C are the right answer. Okay, look at this another one. X is a finite dimension over the C. Any linear transformation here. I think this is simple. First of all, normal, unitary, self-adjoint, unitary. So I can firstly quickly write for you. What is the meaning of the unitaries? T star of T, T of T star, unitary, that is a 1. In terms of matrix is 1. Self-adjoint. So self-adjoint means if you say T is my T star, because over the complex C. Unitary is fine, is a normal. What is the meaning of the normal is? You can say T of T star is equal to T of T star of T. Fine. Then which of the following are there? So now look at that. If T is unitary, it means this property hold. Can you say this happens this value? No. Why? Because if you say T of T star is T of T star of T, it doesn't imply that T is equal to T star. You can consider many examples are there. Fine. If T is my self-adjoint, it means this property hold. Can you say this one? Yes. If I multiply both sides by T, it will be my T star of T. Now what is that T is? I can replace this value as a T star. Fine. So what is the meaning of that? It is my normal. If they are not equal to I, but we need a normal. So this answer is correct. If T is my unitary, it means this is satisfied. Is it normal? Yes, it is already satisfied. This is the right. If T is my normal, if this property hold, can you say T is my unitary? If both are same, is it necessary they are equal to I? Not always true. How? So you can consider any of the example, like simple, any of the diagonal matrix 1 3, say 0 0. Fine. So T star is also your 1 3. Fine. Now clearly says if you multiply them, both are same, but they are not equal to I. Fine. So again you can see for the first example also this satisfied and here. So the right answers are B and C are my right answers. Okay, look at this one. F is a polynomial of degree 4 such that -1 0. So -1 is the root of the polynomial. F of 0 is 0. So -1 and 0 are the roots of the polynomial. 1 is not the root of the polynomial. F10, what is the F1 is? Kth derivative of this. It means f dash of 0 is my 0. F of 0 is my also 0. What is the meaning of that? So 0 is the double root. Fine. Now it has a 4 roots because it has a real polynomial. One root is my -1, double 0 is root, and third root is unknown to us. So I can assume my polynomial will be, if x1 plus 1, it is my x square, so it has a degree 3, then what will be the equation is, it can be ax plus b. Fine, because the leading coefficient may be 1 or may be. So if I open this bracket, what will happen? Okay, what will you do? Which of the following statement are correct? You need to find the third derivative. Fine. So what you do, x cube plus x square, it is ax plus b. So what is that? Can you write this equation? If you open this bracket, you will get ax raised to power 4 plus x cube is a common, is a plus b, then plus b of x square. Fine. Now in all the case you need the third derivative. So what is the third derivative? So you can see the third derivative of this will be 4, 3, 2. 4, 3, 2 is a 12 ax. Third derivative will be 3, 6 a plus b, and it's a 0. Now what is the a and b? So as I see, this is my here, what is the value of f of 1? F of 1 is 1. So what is that? If you substitute here, it's a 1, it's a 2 times x, a plus b is my 1. So a plus b is my half. So if I substitute here, it is my, sorry, it's a 6. What is the third time derivative? It's a 4 first time, then 3, 4, 3, 12, 12 to the 24. So it is my 24 a x, a plus b is my half, so it is my plus 3. This is my third derivative at the point x. Fine. Now look at the options. So now if I clear this screen, so this is my third derivative. Now look at that. What is given to you in the options? There exists a such that f triple derivative. So what is that? F triple dash of a. This is my 24 a square plus 3, which is always be greater than or equal to 3, because if I take a is my 0, then it is equality. Otherwise this number is always positive, this is always positive, so it is greater than. So first option is the correct option. Look at second one. There exists a. So he said for all. Can you say for all f of this? Look at that. It is greater than of 3. If I say f dash of, if I simply say any number in between them, say a is my minus half. Fine. And what will happen? This is 24. No. Sorry. It is f dash of x is, if I take a is my minus half, it is my minus 12x plus 3. Is it a greater than of 3? How you can say it is it a greater than or equal to 3 for all? No. Why? Because a, okay, here is a. Oh, sorry, there is a here is already a is given to you. So I have taken the polynomial as ax plus b. Okay, I think I have used the same a. So I can't use the same a. I use this as a alpha and this is beta. So it is my alpha. Fine. So again I have to relook the first example. First case is third derivative at the point a. So it is 24 alpha a plus 3. So there exists. So can you say a is my 0? There exists a. So that f triple dash of a is my greater than or equal to 3. It's satisfied. Okay. Now if I choose a is my minus half, then it will be my minus 12 alpha plus 3, where alpha is any number. Okay, so if I choose alpha is my 1, then clearly says this is my minus 8, which is less than 0, but he said greater than. So this option is cancelled out. Now look at the third option. Can you say this number is my lies between 0 and 2. So again you can see the same example here. I can choose it's a -8 which is less than of cancel out. Now it's a 0. So it means third derivative at the point 0, it is my 0 plus 3. It is equal to 3. Fine. And for the different value of this, it is also correct. So A and D are my correct option of this example. Okay, look at this another one, which is a similar of the previous question. So you have to define the matrix V. So what is that? V is, I can consider V is my 1, 0, 0. What is the X? X is the element of the, so I can choose the basis of the X cube, E1, E2, E3. So what is the T of E1? It's a E1, 1, 0, 0 minus, what is the, it's a standard inner product, that's a dot product. X, this is the X and V. What is the dot product is 1 divided by V is a unit vector. So it's a 1 into V, 1, 0, 0. So answer is -1, 0, 0. So your matrix will be here. Similarly, can you find the T of E2? It's a 0, 1, 0 minus, what is the dot product of this V with here? It's a 0 times of this. It is 0, 1, 0. Similarly, if you find the dot product of E3, it is again a 0 offset. So it's a 0, 0, 1. So eigenvalues are my +1 and -1. Is it true? You can see the eigenvalues are +1, -1. Determinant is my -1, correct. Trace is my +1, correct. T is my distance preserving. What is the meaning of that distance preserving? If I found Tx minus of Ty, which is nothing but it's an inner product, I can consider here, which is same as of this. So definitely you can see this matrix is my orthogonal matrix. Fine. So each columns is my Li. Each column is my Li. So definitely these properties hold for this. Otherwise you can see this is my C1, this is C2, this is C3. You can choose this is my X, this is my Y. You can find the Tx and Ty. You will see this equality satisfied. Or otherwise you can see T of E1 minus of T of E2. T of E1 is here. What is the difference between them is norm of difference. It is my √2. And what is the X minus Y? What is the difference between X minus is again √2. So all are my correct options. Okay, look at this another one. This is the orthonormal basis. V is a column vector. What is that? It's a 3 cross 3. V1, V2, V3, where V1, V2, V3 are my orthonormal. So if this is orthonormal, what is the matrix A? This is orthogonal matrix. If this is orthogonal matrix, it means A into A transpose is my I, or V into V transpose is I. It is same as of this. Fine. Now if this is, so what is that? It is a wrong. What is the determinant of this? If this is there, eigenvalues are my +1, -1. So the determinant of A is my -1, which is non-zero. So it is also correct option. So A, B and D are my correct answer of this problem. Okay, let VI's are my orthonormal basis. Which of the following are my orthonormal? So what is the orthonormal is? Dot product of U and V must be 0. Very simple. You can write the matrix corresponding to this here. Y1, Y2, Y3, Y1, Y2 here. 1, -1, 0, 0. 0, 0, 1, 0. 0, 0, 0, 1. So clearly says, can you say these two columns are my C1 dot C2? Is it 0? They are not 0. It comes, it's a 0. Sorry, it's a 0. C1 dot C2, is it 0? 1, -1. We need a orthogonal. So it's a 0, it's a 0, it's a 0, it's a 0. So yes, it's a orthogonal. Each of the columns are here. Okay, but orthonormal, dot product is 0, fine. But each column is a unit vector. Is a unit vector? No, the length is root 2. Length is root 2. So the first option is cancelled. Look at the second. y3. This is my y3. y4. This is my y4. This is my y1. This is my y2. Now clearly says each of the columns Ci and Cj is my 0. Fine. Each of that. And norm of the each column is my 1. So this is the right answer. Look at this one. y1, y2, y3, y4. y1, y2, y3, y4. This. Fine. So clearly say that dot product is 0. Fine. What is the length of this? Can you say the length is it the length is 1 by 4 plus 1 by 4 of this? It is not equal to 1. So this option is cancelled. Look at this another one. 3 over 5, 4 over 5, 0, 0. 4 over 5 minus 3 over 5, 0, 0. 1, 0, 0. Now clearly say dot product is 0. What is the length of this? 9 by 25, 16 over 25. So it is a 1. Similarly, this is 1, this is 1, this is 1. So right answers are my B and D are my correct options. This is the first method. Fine. There is one more method you can solve this without constructing the matrix. How you can solve that matrix? So look at that. That way is, look at the first value. y1 plus y2, y1 minus y2, y3, y4. Fine. So what is the length of this? It is 1 plus 1, 2. 1 plus 1, 2. It's a root 1. This is my orthonormal. Fine. Is the same thing? No. So that option is cancelled. Look at this one. y3, y4, y1, y2. What is the length of this? Root 1. Root 1. Root 1. Root 1. Are they same? Yes, they are same. Similarly for this, what is the y1 plus y2 over 2? What is the length of this? 1 plus 1, 2. But it is a, it's a root of 1 plus 1. But it's a 2. But we need a root of 2. So it is again a cancel. What is that? It's a 3 y1 plus 4 y2. So what is that? It is 3 square plus 4 square. It's my 5. Satisfied. 4 square plus 9, 5. It's a root of 1. It's a 1. It's satisfied. So this is also the right answer. So either you can solve it by matrix, or otherwise you can simply choose as a length of this. Okay, which of the following is the inner product on the R? So whenever it's an inner product, you can construct a matrix. If this is a symmetric, then check whether it's a positive definite. If this is a positive definite, then it is an inner product. So we can define it's a x1, x2, y1, y2. What is x1, x2? 1. x1, y2 coefficient is 2. It's a 2. So is it a symmetric? Yes. Now what is the first principal minor? 1, which is greater than 0. Second principal minor is 1 minus 4, which is not greater than 0. So first option is cancelled. Look at the second pair. x1, y1, 1. x1, y2, 1. 1, 2. Is it a symmetric matrix? Yes. So 1 greater than 0. 2 minus 1 greater than 0. Satisfied. It is a positive definite, so it is the inner product. Look at the third option. x1, y1. x1, 1, 1. Is it a symmetric? Yes. 1 is greater than 0. 1 minus 1 is not greater than 0. So it is not positive definite. It means it is not inner product. Look at the last one. 1 minus half, 1. So what is that? It's a symmetric. Yes. First principal minor 1. 1 minus 1 over 4, which is a greater than 0. Yes. So yes, this is the inner product. Look at this another one. This is the June 2023. V the inner product space. These are my orthogonal. Orthogonal means Vi, Vj is my 0. If it is the orthonormal, then the length is 1. The set can be extended to the basis. So for the basis, you need the Li. Write the matrix 1, 1, 2, V1, V2, V3, V1, V1, V2, V3. How you prove this matrix is Li? Either you prove the rank of this matrix is my 3, or you prove determinant is my non-zero. So what is the determinant of this? So 3 minus 2, which is 1, which is non-zero. So therefore this is my Li, and it can be extended to this another one. The vector this can be extended to the orthogonal. The same matrix is here because it is Li, so it form a basis. So you can extend. Can you extend to the orthogonal basis? Yes, you can do by using the Gram-Smith process. Fine. So yes, you can extend it. Look at this matrix: 1, 1, 2, 0, 1, 1, 2, 1, 3. Fine. Now can you find the determinant of this? 3 minus 1 plus of 2, 1 minus 2. So what is that? It is my 2 minus 2, 0. It means it is not basis. But he said it can be extended to the basis, but it is not a basis, so you can never extend it to the basis. Now again, 1, 1, 2, 2, 1, 1, 2, 1, 3. So can you find the determinant of this? So 3 minus 1 minus 2, 3 minus 2 plus of 2, 1 minus 2. So what is the answer of this? 2. It's a minus of 2, it's a minus of 2, which is a non-zero. So yes, you can extend it to the basis because it is Li, so you can extend it to the next basis. Look at one more example. So again, n is not given, so I can take n is my 2. So x will be my x1, x2, y is my y1, y2. So this summation will becomes my I is varies from 1 to 2. Firstly, I can take I is my 1 and where is the j? So it is y1 plus y2. Then I can take x, I is my 2 and vary y1. Fine. So what is that? If I open this, x1 y1, x1 y2 plus x2 y1 plus x2 y2. So can I write this in terms of the matrix? x1 x2 y1 y2, 1 1 1 1. It is a symmetric. Fine. Now check whether it's a positive definite or not. 1 minus 1 0, which is not greater than 0. It is not positive definite. If it is not positive definite, it means it is not inner product. If it is not inner product, then it is not inner product space. Look at this one. I can fix I is 1, so it's a x1 square plus y1 square plus x1 square plus y2 square, plus I can fix I as my 2, then it will be y1 square plus x2 square plus y2 square. So what is that? x1 will be 2 times, y1 will be 2 times, each term will be my 2 times. Fine. Now since it's a 2 cross 2, you are unable to write this in terms of here. How you can prove that? We will check this property. We need this to be here, but definitely this is not satisfied. Why? Because of this square. If I take alpha x comma y, what is the meaning of that? I can replace x1 to be the alpha x1, x2 to be the alpha x2. So this value becomes my alpha square x1 square alpha square x2 square plus y1 square plus y2 square, which is not equal to x comma y over this here. So definitely this option is cancelled. Okay, now look at this third option. I can fix the n is 2, so j is equal to 1. Firstly, j is 1 x1 y1. When j is equal to 2, it's 8 x2 y2. So can you write this matrix? This is x1 x2 y1 y2. x1 x2 is 1 here. Fine. Now is it a symmetric matrix? Is a symmetric matrix? Yes, it's a symmetric matrix. Is a positive definite? Yes, this is a positive definite. So it means yes, this is the inner product space. Look at this one. I can move n is my 2. So this is my xj. This is n is my 2. 2 plus 1, 3. 3 minus j. So if I open this, it's x1, y2. It's x2, y1. So can I write this? x1, y2, 1. x2, y1, 1. It's a 0, 0. Is a symmetric matrix? Yes. First principal minor is 0, which is not greater than 0. Moreover, the second principal minor is also not greater than 0. It means it is not inner product. It's a not. So we have defined the inner. So right answer is only C is the correct answer of this problem. So this is the way you can solve this. Okay, so either you can use this property, but there is no need of them because we are easily able to deal with this symmetric and the positive definite. I hope you can simply learn various tricks to solve this inner product space. We will see the next lecture on the infinite series PY question of the NET examinations. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.